Okay, hi everyone. Today we will be starting with the chapter fossil fuels and combustion and flame. Okay, so now you might have a good idea about what is fossil fuels, coal, petrol, and all that. Okay, non-renewable resources. Combustion, a basic thing about combustion is when we burn anything made of carbon, which is a lot of things, in the presence of oxygen, and heat is also produced. Okay, that is combustion. And flame, okay, fire, flame. We will go into the detail of everything, so let's start. What are fossil fuels? Okay, what are fossil fuels? Now, fossil fuels are natural resources. First of all, they are occurring in nature. Okay, formed from the remains of plants and animals that lived millions of years ago. So I will repeat that. Those remains of plants and animals that went into the earth under high heat and pressure, they converted into this fossil fuels in form of raw carbon, which we burn, we get heat and we get energy. Okay, we get light. These are all fossil fuels. These include coal, petroleum, that is oil, and natural gas. I told you coal and petroleum are both non-renewable resources, also natural gas. Natural gas is not obtained from petrol, it is found where there are reserves of petrol. Okay, coal majorly comprises of dead remains of plants. However, petroleum also has microorganisms through which it was made. Okay, so petroleum had both plants and animals decayed dead in over a lot of years. Okay, but the major component of coal was plants and petrol was both plants, animals, microorganisms and all. Okay, formation. Fossil fuels are formed from the decomposition of organic matter, decomposition under high pressure and temperature over millions of years. High pressure, why? Because it was deep inside the earth. Temperature, inside the earth there is a very high temperature. They underwent decomposition, they underwent a lot of chemical processes, and later they converted into coal, crude oil, natural gas. All this is obtained from inside the earth. How inside? Like we drill deep down into the earth, under the sea, under land, and we find these reserves of coal, crude oil, natural gas, and we take it out. Okay, it is a non-renewable resource, so it is limited in nature. Okay, not infinite. We cannot keep utilizing it forever. It will go all out someday. Okay, so combustion. Now we come to a very important topic called combustion. Combustion is a chemical process. Okay, always remember, it is a chemical process in which a substance reacts rapidly. Rapidly means very fast with oxygen, releasing heat and light. So supposedly I take a paper. Okay, I start burning it. Okay, in the presence of oxygen, it will burn very fast. It will give me heat, it will give me light. Okay, so combustion is something through which a substance is in the presence of oxygen and it reacts very fast with that oxygen to give heat and light. I am doing combustion myself, combustion in the form of respiration. Okay, I consume food. Okay, now I consume oxygen through my nose. My body is burning that food and heat and carbon dioxide is being released. Okay, so respiration is also a form of combustion, but here we are referring to a substance that reacts rapidly with oxygen, releasing a lot of heat and light. Okay, now requirements for combustion. What all is required? First of all, oxygen. Oxygen is very important for combustion. If there is no oxygen, there will be no combustion. Why? Because combustion is of carbon and we add oxygen to it. There is heat. and there is light released to form CO2. Okay, so supposedly there is a fuel made of carbon. I add oxygen, it undergoes combustion, heat and light is released. I put it on fire, there is oxygen, plenty of oxygen involved. It gets converted into CO2 and ash. Okay, cause it gets burned, heat and light is produced. So requirements for consumption include a fuel. I need some source of carbon. I need oxygen. Okay, and I need heat to set the combustion. Okay, the combustion will not carry out unless there is a little bit of heat. Okay, so consider I have some paper, okay, and I also have some oxygen in this room, okay, but they are not catching fire. Why? There is no heat involved yet. Okay, when I put it on fire, a little bit of fire, light will also be emitted more, it will burn. Okay, so fuel, oxygen and heat are the requirements for combustion. Example, burning of wood or burning of paper, both are made of carbon, both will give CO2 when they are burnt. Okay, they both will give heat and light. Okay, so that was it. Now we come to inflammable substances. Now, inflammable substances are those that can easily catch fire and burn. If you see your deodorants, okay, perfumes, there is a warning written behind it, a fire icon says inflammable. What does inflammable means? Means it can catch a flame, it can catch fire easily. Okay, it can catch fire easily and it will burn a lot of fire. Okay, so an inflammable substance can be paper, an inflammable substance can be a candle, an inflammable substance could be petrol. Okay, these are substances that catch fire very easily and they burn. So examples are petrol, alcohol. Alcohol, like as a drink, it can it is very readily burnable. Okay, so inflammable. If I have some alcohol or petrol or gasoline and I add it to fire, the flame would go aggressive, it will burn more. Okay, hydrogen is also used as a fuel. How to control fire and precautions. Okay, how do I control fire? Okay, supposedly now something has caught fire, it is inflammable, it has become very hot. Okay, and the fire is getting out of control. How do I control that fire? How do I control that combustion? Okay, how do I control those inflammable substances that have now caught fire? Okay, first of all, I use fire extinguishers. You can see fire extinguishers are present in many buildings. Fire extinguishing systems are present in buildings and places, so that whenever there is a fire, whenever something catches fire, it will get extinguished by these measures. Okay, so what are these measures? Different types of fire extinguishers are used to control different types of fire. Now there are different types of fires as well. Okay, some large scale fire, some small scale fire. Okay, someone got a little bit burned, but many people got burned. So likewise, different types of fire extinguishers are also used. Okay, supposedly there is an oil tanker, it has got fire. Okay, I will not use a water extinguisher for it. Okay, there are different types of extinguishers, some are gas based, some are water based, some are different. Okay, now if there was some gas cylinder, okay, over a truck, okay, this is a truck, all right, now this has oil or gas, it has burst open and it has caught fire. Okay, now since there is oil involved, I will not use water. Tell me why? Because as soon as I put water over here, oil floats over water. Okay, oil floats over water. Try it yourself. Add some glass, take some water, add some oil to it, oil will be over here, it will not mix with it. As soon as I add water to it, this water will convert to water vapor due to heat, and this oil will be over that water vapor droplets, okay, and the fire can spread and not extinguish. So we use sand, we use gas based fire extinguishers, okay. Water fire extinguishers can be used for wood or paper fires, and carbon dioxide extinguisher. Carbon dioxide is a gas that cuts the flame, that kills the flame, that kills fire, okay. If I have a flame, if I have a candle, okay, if I have a candle, I cut off the oxygen supply by placing some glass container over it. This flame will die out. If I add CO2 to a live flame, okay, I added CO2, this flame will die out, okay. This is what carbon dioxide does. So in a fire extinguisher, in a mechanical fire extinguisher, there will be CO2 present, okay. So when I put it over the flame, the fire will be extinguished, it will be cut off. Precautions. There are some precautions to prevent fire that include inflammable substances away from ignition sources. Now what do I mean by flammable substances from ignition sources? Supposedly there is a petrol pump, okay, they tell you to not use your phone over there, not flashlight over there, not smoke over there. These are flammable substances, okay, flammable substances which can act as ignition to more flammable substances. So now supposedly in the petrol pump there is a lot of oil droplets in the air. You light a cigarette, you use your flash, you light a lighter, a matches or anything, and those droplets of oil in the air, they form a cloud, okay, and this will catch fire easily, okay. So they say keep these flammable substances away from ignition sources, okay. Petrol pumps are ignition sources. You light somewhere and it will lead to a major disaster, all right. Electrical appliances, okay, storing combustible materials properly. Now I know there is a manufacturing plant of paper, okay. A single most fire can burn that whole factory down because all that paper will readily catch fire. So they have measures that no inflammable substances allowed inside, nothing of that sort will come, so that the factory by chance, by accident, will also not catch a fire. So we have to maintain some precautions. What are precautions? We need to be wise, okay, we need to be careful of fire extinguishers and inflammable substances, fire ignition sources, okay. Fire extinguishers should be present everywhere. Now there are types of combustion, okay. What are the various types of combustion? First one is rapid combustion, okay, rapid combustion. What do I mean by rapid? As the name suggests, very fast. It is a type of combustion that occurs rapidly, very fastly, and it produces heat, gives out heat, okay, and light. All combustions do, but what is different about this combustion? It is very rapid, readily. And an example of this rapid combustion is burning of LPG gas. Have you seen LPG being burnt at your house, okay, for cooking? That gas is being burnt very fast, okay. So that is rapid combustion. Now we come to another type of combustion, that is spontaneous combustion. What do I mean by spontaneous? It is the type of combustion that occurs without an external ignition source, okay, due to internal heat generated within the substance. So for this combustion, I don't need any external outside factor or heat to set it on fire, okay. It will have something heat generated from its own. For example, spontaneous combustion of oily rags, okay. suppose there are some oily rags, okay, oily rags placed over uh, some outside wall to, supposedly these are oil rags, okay, oil rags, okay, they are oily and they are placed outside to dry out. The temperature will increase due to sun, okay, and they can catch fire. So this is a spontaneous combustion. I did not go and set it on fire, it caught fire on itself due to internal heat generated inside it, okay. That is a spontaneous combustion. In a rapid combustion, I was burning and it was burning very fast, but in a spontaneous combustion, it was burning on itself, okay. Now I come to explosive combustion. Now, as the name suggests, very fast on a very large scale is explosive combustion. It is a type of combustion that occurs with a rapid increase in volume, okay, occurs with a rapid increase, okay. Supposedly there is a lot of volume of a substance, an inflammable substance, and there is combustion, it has caught fire, but the volume, okay, has suddenly increased, okay. Supposedly there was some explosive firecracker, okay, a firecracker, we've all seen firecrackers, okay. I light it, this will burst open, all right, it will burst. The volume of that combustion, it was only here, now it is so much, okay, now it is so much, the volume has increased. This type of combustion that occurs with a rapid increase in volume and the release of large amounts of energy, okay, it releases a lot of energy, okay, that disrupts or damages, okay, the environment, the surroundings, and it is harmful for people, okay. Security agencies are very precautious of someone carrying explosives, someone carrying any explosive device into public places. Why? Because if it catches fire, it will release a lot of energy and can harm a lot of people. So in metros and in various public places, they have a lot of checking. Why? So that there is no explosive, okay. Explosives can harm people. It is combustion, but at a very rapid pace and at a very high volume at a very big level, okay, at a very big area, okay, it will burn. Example, explosion of dynamite, if you've seen in cartoons as well, TNT, okay, this is a dynamite. TNT, it is used to make tunnels, okay, as an explosive. Explosives have some good applications as well. When we are making tunnels inside mountains, okay, when they are used for getting minerals out of mines, okay, to break that land and get goods and minerals from inside, okay. Explosives are used over there as well, but it can also have an harmful effect. Flame. Now we come to what is a flame. A flame is the visible gaseous part of a fire, okay. So you might think that this is the only place of the candle that is burning, okay. No, this is the only part that is visible to me. There is some combustion happening over here as well, there is heat over here as well, but this visible part, okay, that I can see through my eyes is flame, okay. A flame is a visible gaseous part of a fire resulting from the combustion of a fuel. So if I burn anything carbon and it acts as a fuel, and in the presence of oxygen, if there is oxygen, there will always be a flame, okay. There will always be a flame. Structure of a flame. A flame consists of 3 zones, okay. There are 3 zones. There are three zones. Okay, outermost non-luminous zone. Okay, this is non-luminous. It does not emit light. Okay, middle or luminous zone, this is the yellow part that we see. Okay, luminous. What is luminous? Luminous means giving out light. Okay, innermost dark blackish zone, that is called the core. This is the core. Okay, this is the core. Example, flame of a candle or a gas stove, like I gave you. Okay, so remember this. Fuels. Now what are fuels? Fuels are substances that release energy when they go combustion. Of course, if I burn something carbon and I give it oxygen and heat, it will give me light, it will give me more heat. So this is a fuel. Fuels are of various types: solid fuels, coal, wood, paper, etc. Liquid fuels, petrol, diesel, alcohol, gasoline and all. Okay, and petroleum products. So petrol. Gaseous fuels, fuels that are gas. So gases that can catch fire and give me energy are LPG, natural gas. Okay. Now I come to fuel efficiency. What do I mean by the word efficiency? Efficiency means I use less amount of it, but I get more result. Okay, I use a wise amount of it, but I get a lot of energy, a lot of energy with minimal waste. I will not waste a lot. Okay, so fuel efficiency refers to the ability of a fuel. Okay, every fuel has its different efficiency. Okay, so every fuel has a different ability of heat that it will reduce per volume. Okay, so for example, a flame will give me this amount of heat per this much volume, but on the other hand, petrol will give me this much heat over only this much volume. Okay, so there's a difference. This is efficiency. How much heat or energy I am able to obtain with minimal waste. Okay, I don't want to waste a lot of my fuel, but I want a good amount of energy. That is fuel efficiency. What factors affect fuel efficiency? Factors like the nature of the fuel. Okay, what type of fuel it is? Will it burn easily? Will it not burn easily? Will it give me energy? Will it not give me energy easily? Okay, its combustion process. Alright, you can see over here like the nature of the fuel, its combustion process. Is it combustion? Is the combustion rapid, or is it spontaneous, or is it explosive? The amount of energy I get will depend on that. And the equipment used influence efficiency. Okay, equipment used. Supposedly, I have a torch gun. Okay, a torch gun gives you fire at the end. Okay, so it's like a gun. Okay, it's like a gun with fire at the end. Okay, so it gives me fire. This can be used in many places, like for camping, for cooking and many other things. So this technology is what helping me use this fuel that was inside efficiently without waste. I'm not making a fire, then burning some paper and then trying to cook and all. Okay, so not much is wasted because I'm using technology. So this equipment used to influence the fuel efficiency. Okay, this is also plays a major role in affecting fuel efficiency. Okay, so vehicles with higher fuel efficiency can travel more distance with less fuel. Consider a good example would be Alto or a car or any other car. Okay, in earlier times, the cars that used to come, they required a lot of fuel, but they couldn't travel a lot of distances. Okay, there was less mileage. Okay, mileage. Nowadays we see on less fuel, on 1 liter of petrol, you can travel a lot of distance, 30 kilometer, 35 kilometer, okay, on an average, a lot of kilometers, okay. That is the efficiency of that car, okay. It can give you more energy over less time and less fuel given, okay. That is efficiency. Now we come to harmful products obtained from burning of fuels, okay. What are the harmful products obtained from burning of fuels? Like I told you, I get carbon dioxide. Carbon dioxide is a greenhouse gas. It is contributing to global warming, okay. It is not good for the environment, but it is released due to combustion. C plus O2, heat, light, CO2. Okay, it is not that good for the environment, but it is used by plants for photosynthesis. But a lot of it is bad. Carbon monoxide, a poisonous gas. I have told you carbon monoxide is CO. When is it produced? When carbon is burned with only less oxygen. Less oxygen gives me CO. Okay. Sulfur dioxide, SO2, it causes acid rain and respiratory problems. SO2, this is obtained from burning fuels, sulfur, firecrackers, for matches, and from your cars. Sulfur is removed, obtained, and it goes into the atmosphere where it mixes with rain and it comes down as acid. Okay, and it causes respiratory problems. Sulfur dioxide, it causes acid rain. Particulate matter, PM, okay, tiny solid particles suspended in air which can cause respiratory issues. So burning of fuels will cause particulate matter, which comes from your cars, homes and trucks and industries. They all release particulate matter. These are tiny particles suspended in the air which makes breathing difficult, asthma and all these difficulties, respiratory diseases. Nitrogen oxides. Now nitrogen oxides contribute to pollution and smog formation. Have you seen smog in Delhi in winters? There is a lot of smog, smoke plus fog, okay, such that visibility is even very low, okay, you cannot see. There are a lot of nitrogen oxides, okay. Nitrogen oxides make visibility difficult. They contribute smog, they contribute to air pollution, they also cause acid rains. So these are all the harmful products obtained from burning of fuels. Alright, so that will be enough for fossil fuels, combustion and flame. I hope you enjoyed. Thank you.